Martin, and I had 0 dropouts in 6 hours. So I don't understand why it drops out here. All right, now, can we combine some like terms? Yeah, definitely right here. It's 4x squared plus 12x. And then what do we need to get it equal to? 0, right? Because it's got x squared in it. Minus 6x minus 18. 4x squared plus 6x minus 18. What's everything divisible by? 2. I'm just going to, at this step right here, divide everybody by 2 because I see that everything's even. So if I divide everybody by 2, technically the 0 as well, that's going to be 2x squared plus 3x minus 9. Okay. What method do you want to use to solve that one? X method? Let's just try that. So what goes on the top? Negative 18, 3 on the bottom. Multiplies be negative 18, adds be positive 3. 6 and negative 3. Good job. So can I go straight to x plus 6 and x minus 3? No, I've got to do the long way of factoring here. That's 2x squared plus 6x minus 3x minus 9. And then what do I do from there? Group. Good job. 2x, x plus 3. What do I pull out of the second group? Negative 3. Good job. X plus 3. So my factors are then x plus 3 and 2x minus 3. What do I do with those? Set them equal to 0. So x plus 3 equals 0. 2x minus 3 equals 0. There's and x would be 3 over 2 for the other one. All right, so what do we do with that one? Throw it out. Just put an x through it like that. I can still see that it's there, that you found it, but you threw it out because it. Why did we throw it out? It's an excluded value. So the only solution we have for this one is 3 over 2. We found negative 3, but it's thrown out because it matched one of our excluded values.
I'm going to ask, why did you do 18 instead of say like 9?
Because you got to multiply a times c, whatever's in front of x squared times the constant on the end. That's how you remember how to do the x there. If there's nothing in front of x squared, then it is the same number as the end. But if there's a number in front, you got to multiply to get there. I'll be honest, a lot of times if it's a trinomial like that, I'll just go to quadratic formula, straight away, because sometimes it's hard to find that pair. But if you want to do factoring, that's fine. Just keep in mind you need to be able to do quadratic formula sometimes. All right, let's look at, bless you. One minute. Let's say you had say we had 1 over 3x plus 9 plus 1 over 3x squared plus 15x plus 18 equals 1 over 3. A little bit, not that much harder than the last one we did, but still a little bit more factoring involved in the denominators. So first thing we want to look at is the denominators and try to factor them if at all possible. So The first one, 3x plus 9, will it factor? How? GCF of what? 3. So that's 3 parentheses x plus 3, right? What about the second one? Does it have a GCF? Yeah, 3 comes out. That's x squared plus 5x plus 6. But will that trinomial factor? Yeah. Multiply to be 6, add to be 5, 3 and 2. So that's going to be x plus 3 and x plus 2. So this is the factored form completely of the original denominator. And this one doesn't factor, we know that. So, okay. So again, you want to factor your denominators first, see if you can see what they have in common. So that helps us find the least common denominator. What would the least common denominator have in it? The 3, because everybody's got a 3, right? That's a shared piece. And then these two both have x plus 3. And then there's another piece, the x plus 2, that only one of them has. But the product of all of those has got to be the common denominator. Okay? How do we find our excluded values again? Equal them all to 0. So what about that 3 that's in front? What's it do? It can't, yeah, it goes away. So it just got x plus 3 equals 0 and x plus 2 equals 0. That's negative 3, negative 2. So those are your things x cannot be. All right, so then now we go back and we fix the fractions. What does the first fraction need? Needs an x plus 2. So top and bottom get x plus 2. What's the second fraction need? Nothing. Or as my little boy says, nothing. Don't need nothing. All right, what's the third one need? Yeah, it needs both of the binomials there, x plus 3 and x plus 2. All right. So now we've got all the denominators the same, so we just need to multiply out the numerators. So at 1 times x plus 2 is just going to be x plus 2 over 3, x plus 3, x plus 2. The second one, you didn't do anything to it. The third one, what do we know x plus 3 and x plus 2 multiplies together to get? That right there, doesn't it? Because that's where it came from. So x squared plus 5x plus 6 over 3 x plus 2 x plus 3. All right. Denominator does what? Goes bye-bye. So x plus 2 plus 1 equals x squared plus 5x plus 6. So we just drop the denominators and get the numerator equation. X plus 2 plus 1, x squared plus 5x plus 6. Once we get here, it's back to a quadratics equation, which is stuff we did back in, well, I guess it was maybe September that we were doing this stuff. So what do we got to get it equal to? 0. So I can combine this and x plus 3 and then start moving stuff. If you wanted to start moving stuff at the beginning, you could. It doesn't matter. I don't care how you do it, as long as you get it equal to 0 and everything's legal mathematically. So I'm going to subtract 3 and subtract x. It's going to be x squared minus 4x plus 3. I think x method will work on this. Multiply to be 3, add to be negative 4. Is it positive 4? It is positive 4. Even better. X method will work on that too. 3 and 1. So x plus 3, x plus 1 Set those equal to 0. -3 and -1. But -3 is an excluded value, so we throw that one out. -1 is the only solution to that. All right. So get the denominators the same, get your excluded values, fix the fractions, get the numerator equation, solve it. That's your job. As your